Okay, guys, let us take a look for today's class. Okay, yesterday we stopped at the introduction of the divided difference, and then we introduced how we are going to find the constant A0 and A1. And the next one is I do ask you guys to look at how we are going to find the next constant that is a A2. So it's a similar way, just like how we are going to find A0 and then the A1. So remember, to find A0, we substitute x equal to x0, right? And then to find the A1, we substitute x equal to x1. So this is what we have seen yesterday. All right, so yesterday I've discussed about this. So now if you want to find A2, so we need to substitute x equal to x2. Okay, so now we know that in order for us to find the A2, we need to substitute x equal to x2 into the p function. So this is what we have. Okay, now remember, we have found that our A0, this is equal to fx0. Okay, so and our A1, remember that we have found that this is equivalent to f, actually is I write it in the square bracket, x1, x0 and x1. So this is what we have found for the A1, which is equivalent to fx1 minus fx0 divided by x1 minus x0. Okay? So what you're going to do is you have to substitute into the equation here. Okay, so you substitute into the equation. So we know that this is your A0 and we know that this is our A1. Okay, so when you substitute and we know that this A2 will become our target. Okay, so we want to find what is our A2. Okay, so P and X2, this one we know, this is actually equal to our Fx2. Okay, so all the information that you have, and then you do some math calculation. So at the end, you will encounter this one. Okay, so when you get this one, so this one I will leave it for you. The computation here, I will leave it for you. You should be able to do this. Okay, here we can see that there is a similar factor here that you can factorize it. So I factorize it, and this is what we left. Okay, so from here we know that this is actually, this formula, they are equivalent. So I can write this formula in the terms of f divide the difference. This is the x0, x1, and x2. Okay, because they involve 3 points. So that is the x0, x1, and x2 points. Okay. So this is a general form. If you want to find A3, let's say, okay, let's say you want to find A3. So how you going to do it? So you need to substitute your x equal to x3 into the Pn function. Okay, so then you'll be able to get your A3. All right, so now I will give you the general formula. So this A is a constant that we have discussed. So it is a general formula that we can write in the terms of the divided difference. So you see, this will be your general formula where AK is equal to F. You see, I'm using the square bracket. So you must be careful of this bracket. Okay, if you use a round bracket, it will be wrong. Okay. So this is x0 and next, and then x1, x2 up to xk. So you see, if your k is equal to 0, so we know that xk here is represent 0, right? x0, right? So that means you know that a0 is equal to f x0. So this is, if you have only one term here, so we know that this is equivalent to fx0. Okay, now if your k is equal to 1, so that means I have a1, so I know that my last x here is x1, so that means I start from x0 comma x1. Okay, so if let's say my k is equal to 5, that means my a5 is actually equal to f. I know that I start from x equal to 0 and at xk. So what is my k now? Now it's 5, right? So that means I start from x0, x1, x2, x3, x4, and n at x5. So this will be your a5. All right. Now, what is the general formula for this function divided difference? Okay, this f. So for the zero divided difference, so zero means that you have only one term. So our fxi is equal to fxi. Example, okay, we have fx0. So this is equivalent to fx0. The bracket, you can square bracket become the round bracket. Okay, so if you have, this is called zero divided difference. Another example that I can give it to you, if let's say if I have fx5, so this is equivalent to the square bracket is equivalent to the round bracket. Okay. Now, first divided difference. Okay. So the first divided difference we have two. If you see, this is the formula f xi comma xi plus 1. So the formula will be f xi plus 1 minus f xi divided by xi plus 1 minus I. So for example, if my I is equal to 0, then I have my f x0 xi plus 1 that is equivalent to 0 plus 1. So this will give us 1. So the formula is equal to f x1 minus f x0 divided by x1 minus x0. This is equivalent to, because this is a 0 divided difference, right? So the 0 divided difference, I can write it using the round bracket. So this fx1 minus fx0 divided by x1 minus x0. Okay? Now, for the second divided difference, so we have xi, fxi, xi plus 1, and then xi plus 2. So the formula will be fxi plus 1, comma, xi plus 2, minus f xi, comma, xi plus 1 divided by xi plus 2 minus xi. Okay, so here you need to be extra careful, okay? So you need to be extra careful. This is, you take the smallest at the first and the last element, and then you divide, you take the subtraction, all right? So in general, okay, for the k divided difference, okay, so this is a general form, okay? So for the k divided difference, you can write in terms of this formula, all right? Okay, so I think it's better for me to show you the table, okay, how we're gonna calculate the divided difference, all right? So suppose usually in the exam, this data set will be given. Okay, this one usually will be given, but not the first divided difference, second divided difference, and the third divided difference. All right, this one usually you need to calculate by yourself. All right. However, if it is given, then you have to use the information that given to you. All right. So now you see first divided difference. So what is the formula in general? So first divided difference, the general formula is this one. Okay. So if you feel like you afraid that you can't remember, so you can write down the formula here. So we know that f xi and then xi plus 1, the formula is equal to f xi plus 1 minus f xi divided by xi plus 1 minus fxi. Okay, so this is your first divided difference. So this is the formula. So you see, so when your I is equal to 1, okay, I equal to 0, okay, so we start from I equal to 0, so I have a 0, 1. So f0 and x1, so the formula is fx1 minus fx0 divided by x1 minus x0, okay? So what you're gonna do from here will be, you start with I equal to 0. Next, I equal to 1. So when your I equal to 1, so here is x1. Xi plus 1 will become x. I is 1. 1 plus 1 is equal to 2. So you have x1 and x2. So this is how we get x1 and x2. So next, you substitute into the formula that where we have I equal to 1. So we have f2 minus f1 divided by x2 minus x1. So this is how we get this formula. All right, and you proceed for the next one. Okay, second divided difference, also the same thing. We use back the formula. So the second divided difference is here. Okay, so you can use this formula directly. Okay, And for the third divided difference, so if the third, so that means third, we have the k equal to 3. Okay, so when your k equal to 3, you substitute here, your k is equal to 3. Okay, so you substitute all the k equal to 3. So then you'll be able to get a formula. So this will be the third divided difference formula. Okay, for this is here. Okay, you need to be careful. Okay, so how we're gonna compute the value will be, to find the first divided difference, what you're gonna do will be, first, we take this value minus this value, divide by this value minus this value. Okay, next we get this from this value. Okay, now to calculate the fx1, x2, what you're gonna do will be, we have to take fx2 minus fx1, okay, divided by x2 minus x1. So we get this value. Okay, next, we would like to calculate f x2, x3. So we have to take fx3 minus fx2 divided by x3 minus x2. Then we will be able to get this value. Okay, now to calculate the second divided difference, okay, what you have to do, so first we have to take this value, we want to calculate f, x0, x1, x2, right? So you have to take this value, okay, minus this value, okay, divide this value minus x0. You get this value. Okay, next, if we want to get this value, the fx1, x2, x3, what you're gonna do will be, we have to take this value minus this value, okay, divided by this x3 minus with x1. Then you will be able to get this value. Okay, now to get the third divided difference, there is your fx0, x1, x2, x3 to get this one. So how we gonna do it? So we have to take first this value minus this value divided by x3 minus with x0. Then you'll be able to get this value. Okay? So I hope that it is clear. Now, guys, this is very important. Can you see it is overlapping? So, for example, if you calculate this fx0, x1 wrongly, all your calculation will be affected. Okay? So be careful when you do your calculation. Make sure you do it correctly. One is wrong, everything will be wrong. Okay, so this is, I give you the warning. All right. Okay, next. Okay, having the above divided difference, so equation star is actually we referring to this equation. Okay, this is the equation that we refer to. All right. So this equation will become this one. You substitute what is your A0, okay? So we substitute what is our A0, what is our A1, those A terms. So, okay, you substitute all the A term, you'll be able to get this because our A0 is equal to Fx0, A1 is equal to Fx0, x1, and A2 is equal to Fx0, x1, x2. So I just write it like this. So this is equal to A0. This one is equal to A1. We know that this is equal to A2. If you have AN, this is equal to our AN. Okay, the rest you maintain the same one. Okay, so you see this multiplication of the factor, you get back the same thing. Okay, so you see I highlight it so that you can see better. Okay, so now next can write the summation because it's a plus, right? So the summation of the f we can write in a general form. Okay, so you see when your k is equal to 1, we refer to a1, right? So a1, so that means our k is equal to 1. So first started with x0, we end at x1. So you get the a1. And we know that we are going to multiply with this one. K minus 1 means that when your k is equal to 1, our k minus 1 is equal to 1 minus 1. This gives us 0. So we have x minus x0. So that means we only have this term. So this is how we get this one. Okay, so this is how we get this one when k equal to 1. Okay, so when k equal to 2, what happened will be when k equal to 2, okay, k equal to 2, we have x0, the first element, and the last one is x2. So that means we have x0, x1, and the last one is x2. Okay, so this is equivalent to this. All right, next, we have k minus 1 is equal to 2 minus 1, that is equal to 1. So we have x minus x1 is the last one. So we start from x minus 0 and we stop at x minus x1. So this is how we get this one. All right. So if your k is equal to n, what happened? K equal to n. So you start from x0 and you end at xn. Okay, xn is your last one. So here, the last term here will have n minus 1. All right, so you start from x minus 0, x minus 1, dot, 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 until the last one is x minus n minus 1. All right, so now this is some of the textbook, either you can write in this form, okay? All of these, they are the correct one, okay? Or some of the textbook, they may use the last line, okay? If you see some of the textbook, they use like that, where they take, because this is multiplication of the factor, right? So we can write it in terms of the multiplication of the factor. And here, FII represent, FII is equal to this one, the f x0, x1, dot, 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 until xi, okay? So it's up to you. So all of these, you can be used to write the equation, all right? If you ask me, which one I prefer. Okay, if you ask me which one I prefer, to be frank with you, I prefer this one. Okay, I prefer this one because this one is easy to read, to memorize. Okay, this one is a bit challenging because we are not getting used of the FII thing. Okay, but if you like it, then you can go ahead. But if you ask me personally, I would prefer this one. Okay, but it's up to you. All of them are similar. Okay. Now, so what does this formula call? So you have to know that this formula, the name of this formula is called Newton's, okay, divided difference formula. So I use capital DD to represent divided difference, all right? So this is the Newton's divided difference formula. Sometimes the question will be sound like this, okay, given a set of data point. Okay, by using the Newton's divided difference formula, find the polynomial for the above data set. Then you must use the Newton's divided difference formula. All right. Okay. So, okay, this one is information that you can have. Okay, so we know that how you are going to find the value when you are given a function p and x, okay? So for example, if you are given a function p and x like this, if you want to ask you, please find, for example, find p and 3. So what does it mean here? It means that we have to substitute x equal to 3 into p and x function, okay? Then you'll be able to get the value. So in this case, okay, so you see, when this one means that our x is equal to x0, what do you get? All the terms here, you will get x0 minus x0. So this is equal to 0. Anything multiplied by 0, you get 0. So you see here, you get 0, right? So everything here will be 0, everything will be 0. So you only left this one. Okay, so this is how we get Pn x0 equal to fx0. Okay, if you are given, okay, I pick arbitrary example. Okay, let me erase this one. Okay, so let's say we pick our x is equal to x2, okay? X equal to x2, I know that this one is okay, but not here, because here, if you see carefully, you have x minus x0, x minus x1, maybe the next one you have a x minus x2, right? So what do you get means that here x minus x2 is equivalent to your x2 minus x2, right? This one will get 0. So that means this one you gone. So you only left this one, and this one. Okay? So this is how we get this one. Okay? And the rest you can try to look at it by yourself. Okay? So I'm not going to repeat the same thing. Okay, so now, suppose for the above case, we have 4 data points, okay? Always remember, if you have 4 data points, your n here is the most is 3, okay? So you have 3. Now, if you have 10 data points, what is the Pn that what is the n here that you're gonna get? You have 10 data points, so you will be able to get P9, okay? Just 1 degree less, okay? P9x, you'll be able to get P9x. So if you have 100 data points, okay? So 100 data points, you will get P99x equal to blah, 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 all right? So this is the concept. Okay, now, let us take a look for this example. Okay, so far, do you guys have any question before I proceed to example? Okay, no question. Okay, if no question, let us take a look for example 13. Okay, now I would like to let you know divided difference is one of the famous section. Okay, especially in exam. Okay. Okay, now for example, you are given a data set, so you can see how many I. Actually, you can add a column if you want. Okay. If you want to use I also can. If you want to use N also can. It is up to you, okay? So let's say you want to use I, okay? So this is our I. So we know that we start from 0, 1, 2, 3, 4. So we have 4 up to the I maximum is 4. So that means we have how many data points? We have 5 data points. So you see 1 data point, 2, 3, 4, 5. 5 data points, so you will be able to get P4. Okay, you go able to get P4. So we know that this value is equal to x0. We know that this is x1. We know that this is our x2. We know that this is our x3. And we know that this is our x4. This one, we know that this is a fx0, okay? We know that this is our fx1. We know that this is our fx2. This is our fx3, okay? And this is our fx4, all right? Okay, so this is our data point. Next, you see, complete the divided difference table using the information above and construct interpolating polynomial that uses all these data. So they want you to build a divided difference table. So what does it mean? So actually, they want you to build this table. Okay, so this is a divided difference table. Okay, so this is the table that we are looking for. All right. After that, you want you to find the polynomial. All right. So you do the table first. Okay. So in order for you to plot the table, of course, you need to expand this table. So what you're going to do, so for me, I prefer in the table. So please allow me to use this. I prefer this one to be represented by xi. Okay. And this one, you can write it as fxi when you draw a table, okay? Next, I expand from this table, okay? So next we have first, okay, the divided difference. This is xi and then xi plus 1, okay? Now, I would like to ask you, okay? We have 5 data points, okay? What is the highest number that we're gonna get for the divided difference? We have fxi plus 1. Next, we have fxi, and then xi plus 1, and then xi plus 2, right? So I want to know what is the last xi that we're gonna generate from here. How many divided difference we're gonna have it? We have 4, okay? So 5 data points will give you the largest is 4 divided difference, okay? So that means the next one you're gonna have, this is f, start from xi, then dot, 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 until the last one, this is xi plus 3. Okay, so xi plus 1, xi plus 2, next xi plus 3. In the exam, you must write full, okay? Here, because I do not have enough space, all right? I do not have enough space, so I need to write in short. Okay, and the next one you're gonna have is start from fxi, next xi plus 1, next xi plus 2, next xi plus 3, and the last one is xi plus 4. Okay, so you're gonna have this. All right. So what I'm gonna do is we do the first divided difference first. How to find the first value? Okay, the first value for this is our fx0, x1, correct? So the formula for this is fx1 minus fx0 divided by x1 minus x0. So that means we're gonna take the value of this one minus this one divided by this one minus this one. Okay, so I actually obtained this is negative 0.48. Okay, I need to write smaller size. Okay, maybe I should type it. That's better. Okay, so I actually get it. This is negative 0.4837057. Okay. Next, I would like you to calculate at home. Okay. You try at home. I give you the answer, but you need to try. Okay. The next one, it is in between fx1 and x2. Why I write like that? Because the next calculation for the first divided difference will be fx1, comma, fx1, comma, x2. So the formula is fx2 minus fx1. I think I'm not going to write the formula. You can refer to your notes, all right? So I give you the answer here. So the answer that we're gonna get from here is, this is negative 0.5489460. Okay, I do these two for you, then you can check it out. Okay, how we get this? What is our fx1? Our fx1 is 0.6200860 minus fx0. So this is our fx0. So this is 0.765197 divided by x1 minus x0. x1 is 1.3, x0 is 1.0. Okay, so this is how we do the calculation. For the next one, how we get a negative 5489460? We take the fx2, so this is the fx2, so we have 0.4554022 minus fx1, that is 0.6200x60 divided by x2, so this is our x2 value, so 1.6 minus x1, 1.3, so we get this value. Okay, and the next one, I give you the answer here. So I would like you to try at home. Okay, so this is negative 0.5786120. Okay, and the last one that we're gonna have is negative 0.5715210. Okay, okay, next. To calculate this, the second divided difference, okay, let me erase this one. Maybe I need the space. Okay, so now let us come back here. So we want to calculate f when I equal to 0. So we have x0, x1, and x2. So what is the formula? The formula is f x1, x2 minus f x0, x1 divided by x2 minus x0. Okay, so what is our fx1 minus x2? So the value is equal to fx1, x2 is this one, okay? Is this value, this one, all right? So we have, this is equivalent to negative 0.548940 minus, this is the value that we have for x0, x1, so minus negative 0.4837057, okay, divided by x2. So what our x2 is 1.6, our x0 is 1.0, okay? So you calculate this, and I actually obtain the value. So how you gonna write? You write this value, okay? First, let me show you how we're gonna write this value. Okay, in order for you to write this value, let me highlight. Okay, we write this value in between these two. Okay, in between. Okay, next, we write this value in between these two values. Tengah-tengah. Okay, next, we write this value which is in between this and this value. Okay, and the last one is we write this value in between this and this. Okay, now for us to write, the next one is this value, right? We write in between these two values, so I put it here. Okay, so my answer is negative 0.1087338. Okay, so that means I actually write this. Okay, this value is actually in between these two. Okay, and the next one, okay, I want you to try at home. So I give you the answer here. So the next one is in between these two values. I actually get negative 0.0494433. Okay, and the last one here, I have 0.0118183. Okay, so, and again, it's a similar concept. Okay, how you gonna get this value? It is in between this value and this value. Okay, so how you are going to get this value? It is in between this value and this value. You write in between. Okay. So next we proceed to the next, the third divided difference. So for the third divided difference, okay, we have when I equal to 0, we have xi is equal to start from 0 and then up to 3, okay? So I'm gonna add one more term here. So I have up to 3, x3, okay? x3 is equal to, so I have start from x1, x2, and then I want to add one more. So I add with okay, x1, x2, x3 minus f x0, x1, x2. So this is x3 minus x0. Okay, so I have this value, you substitute f x1, x. So this is, okay, this is the value of f x0, x1, x2 equal to this value. This value is f x1, x2, x3 equal to this, okay? And I have this value is equal to f x2, x3, x4. Okay? So now I have to take, let me erase this one. Okay, so I have f x1, x2, x3. This is equivalent to negative 0.04944433 minus negative 0.1087338 divided by x3, it is 1.9, x0 is 1.0. So I will be able to get the value of 0.065878. So you fill in this value into this table here. So you fill in here, okay? So we fill in here, I get this is 0.065878, okay? And I give you the next one, okay? It is in between these two values, okay? So I have this value is 0.0680684, okay? Now, how to write this value? So this value is actually in the middle of this and this value at the center, okay? Oh, okay, let me do this. Okay, I think I do not type it in the center, so let me do this, okay? I delete this. I should write in the center so that you can see better. Okay, a bit down here. Okay, here, 0.06587883. Okay, then I need to remove this one, put it a bit down here. Okay, I think it do not move much. Okay, 0.0680684. Okay, so I highlight this. So this one is in between this and this value. Okay, so this value is in between this and this. Okay, now you should know that this value is represented by, let me write in, this value is f x0, okay, x1 dot 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 x2 and then x3 equal to this value, okay? And this value is represent f x1, x2, x3, x4. This is 4, okay? You see better? Maybe I write it nicely. Okay, this is 4. Okay? And the last one is this one. So how to get the last one? So let me do some. I erase this one first. Okay. So the last one that we're gonna have will be when I equal to 0, we have f x0, and the last one dot 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 until x4. Okay, so you're gonna take f1, 2, 3 dot 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 until the last one. This is 4. Okay, and minus x0, x1 dot 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 until the last one. This is until 3. Okay, and then we take the big number and the small. So this is the largest x, this is a smaller. So we take x4 minus x0. Okay, next we substitute the value. So we substitute the value here. Okay. So x1 dot 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 until x4, we have 0.0680684 minus this one. This is 0.0658783 divided by x4. This is 2.2 minus x0, that is 1. Okay, so I actually obtain this is equal to 0.0018251. So you fill into this table here, right in between these two. Okay, here is my in between. So I have 0.0018251. Okay, so you see, this is actually in between these two values. Okay, so basically this is the table that we are looking for. All right, so I hope that you know what is this value all about. Okay. Okay, guys, do you know what is this value represent? Okay, I just make sure you know this is your fx0 x1 equal to this. This value is your fx1 x2. This value is fx2 x3. This value is your fx3 x4. Okay, so this is how we get the value. All right. So now we are done for the first divided difference table. So next we need to construct the interpolating polynomial. All right. So which formula that you need to use? That one you need to identify. Okay. So we are going to use the formula that is this one. Okay. We use this one. So let me erase this one first so they can see better. Okay, so this is actually the formula that we are going to use. How we get this formula? This is from here. Okay, from here. Okay, from this double star star. Okay, this is the equation that you need to remember. All right, so we are going to use this formula in order for us to find the interpolating polynomial. Okay, so let me erase this one. First part, you are done. Now is the second part. So we know that our Pn, what is the value of our n? Our n is equal to 4, okay? Okay, so for me, I actually like you guys to practice. Write down the general formula first. Okay, what is the formula for the Newton's divided difference formula? So the formula is actually Pnx, okay, equal to fx0 plus fx0 comma x1 times x minus x0. And next we need to plus fx0 x1 comma x2 times x minus x0 times x minus x1. Next, plus with a fx0 x1 x2 and x3, okay, times with x minus x0 times x minus x1 times x minus x2. Next, we have plus with f x0, x1, dot, dot, dot. The last one is x4 times with x minus x0 times x minus x1 times x minus x2 times x minus x3. Okay. So what you're gonna do, substitute the value, okay? You know what is the value, you have found it, okay? Because the divided difference table you have created, so you substitute all the value there. So F0, we have this value, okay? This is our F0 value, so you substitute. Okay, so I actually obtain, this is, so now, I have Tn, what is your n here? N is 4, okay? N is 4. P4x is equal to fx0, referring to the table. we have 0.7651977. So put it here, okay? So we have 0.7651977, okay? And next, what is this value? So this value, oops, where we are, okay, this value is equivalent to this value. Okay, you're gonna substitute this value into the equation, all right? Actually, you need to take this value, maybe I put it here, this value, this value, this value, this value, and this value, substitute into the formula, okay? So I'm gonna do, okay, and then plus, okay, plus, but that one is negative, right? Plus and minus become minus 0.48370057 times x minus 1.0. Okay, and then next is minus 0.10x7338 times x minus 1.0 times x minus 1.3, and then x plus 0.0658783 times x minus 1.0 times x minus 1.3 times x minus 1.6. And the last one, it is plus 0.00182251 times x minus 1.0, x minus 1.3, x minus 1.6 times x minus 1.9. So this will be the answer. Okay, if the question asks you to simplify, you need to simplify. Okay, but if the question does not ask you to simplify, you do not need it. Okay, so this will be your answer. Just leave your answer like that. Like this will be good enough. Okay, unless the question asks you to simplify. If you simplify, you need to solve this factorization. Okay. Now, guys, what happened if in the question they suddenly add another one, ask you to find add P for 1.5. So how you gonna do this? So the solution will be, let's say, asking you to find this. So how? You need to substitute x equal to 1.5. So I highlight. So you need to substitute your x equal to 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, all over the x. Okay? So when you substitute x equal to 1.5, you will be able, I will leave this to you. You try at home. Can you get the answer is equal to 0.5118200? So this is the answer. Okay? So we basically done with this example. Okay? So any question about example 13? No? Okay, this example 13 is very important because you're gonna use it a lot, okay? Because after this, you're gonna see the Newton's forward, the Newton's divided difference. This is the first one that you have seen. The next one you're gonna see Newton's forward difference formula, Newton's backward difference formula, and then you also have another one, is a Newton's center difference formula. So there are many more, okay? So now what we're gonna do will be next, okay? We were going to introduce you more Newton's formula. So actually we need to discuss for the next is a Newton forward difference formula, okay? So before we begin with the discussion of the Newton's forward difference formula, let us take a look first, okay? Based on the Newton's divided difference formula, what we can do, okay? So you see, Newton's divided difference formula can be expressed in a simplified form, okay? See, simplified form, when the nodes are arranged consecutively with equal spacing. So means that now we look at the simplified form of the Newton's divided difference by considering the nodes are arranged in the equal spacing order, all right? Equal spacing means that the difference between the x, they are equivalent. So what does it means will be the size from x1 to x0 to x1. So they are similar. So for example, like this case, the difference between x0 and x1 is 0.3. The difference between x2 and x1 also 0.3. The difference between x3 and x2 also 0.3. And the difference between x4 and x3 and x4 is also 0.3. So this means that this is an equal spacing. Okay? So this is what we mean. Okay? So now let us introduce you H. The formula for H means that it's a space, okay? The size, the step size, okay? Some of the textbook, they call it as a step size. So the H is represent the step size. So the formula is xi minus xi plus 1 minus xi, okay? Where your I start from 0 up to n minus 1. And we let x is equal to x0 plus s times the H, okay? So these two are the so-called the formula, right? So that you have to remember. And you must know that your I start from 0 and the last one is n minus 1, okay? Because when n minus 1, when I plus 1, where your I is equal to n minus 1, you will get xn. So we know that xn is the last node, okay? The last node that we have. So now we want to find the difference between x minus xi. So how we can get this formula? So first we know that we have a h is equal to xi plus 1 minus xi. Here we call it next we can find our xi form by moving xi to this side and moving h to this side. So I will have my xi equal to xi plus 1 minus h. So this is our equation A. And our x equal to x0 plus sh is from here. Okay, it's from here. So this is equation B. Okay, so now we want x minus xi, right? So means that I have an equation B minus A. So B minus A, so we have x minus xi. This is the one that we have equal to this one minus this one. So this is what we have, okay? So when you simplify, okay, I will have x0, okay, plus sh, okay, minus xi plus 1 plus h. So what is our xi plus 1? Okay, if you see from here, okay, so I can have, okay, h, you see, h is equal to xi plus 1 minus xi. I want to know what is this. So what I'm going to do, I move this one to this side. So that means my xi plus 1 is equal to h plus xi. So you substitute this into here. Okay, so this is what we get. Okay, why you have a negative? Because you have a negative here. All right. Next, we can simplify. So 1, we have a minus h and positive h. We can cancel. All right. So now we have x0 minus xi plus sh. So you can factorize it. So you have a minus xi minus x0. This is actually equivalent to I times the h. This is the how many spacing we have. So for example, x1 minus x0, we know that this is equal to h. If we have a x2 minus x0, this is equal to 2. Actually, if you can see, sorry, why I draw here. This is actually, we can begin with the spacing like this. This is x0, this is x1, this is x2, right? So we know that the difference here is h. Difference here is h. So if x2 minus x0, this is equivalent to 2h. Okay, so this is equivalent to 2h. So if I have xi minus x0, so that means I will have I times the h. Okay, so you see, you can see from here, because here is 2, here is 2. If I, then here we have I. Okay, so this is what we get. Okay, you can factorize, and at the end, you get this formula. X minus xi is equal to h times s minus I. Okay, so next, what you're gonna do? Okay, remember, this is your Newton's divided difference formula. Okay, this is a formula. So what you're gonna do is we want to substitute the x is equal to x0 plus sh. Okay, how you get this information? It is from this page. Okay, it is from here, this one. Okay, so now we're gonna substitute the x. Okay, what you're gonna do is we like to substitute all with the x here. Okay, so x here and the x here and the x here. Okay, and you see we have the x here, right? Okay, and we have also x minus this one. We also can consider. Okay, how we want to do substitution here. Okay, so from here we can get x minus x0 equal to sh. Agree? Okay, so what you're gonna do? You have to substitute x minus x0, so this is equal to sh. So that's how you get the sh here. Okay, so the same thing, you proceed here. You have sh. What about your x minus x1? Okay, x minus x1, how you gonna get it? You have to use this formula, this one. So x minus x1. So what does it mean? It means our I equal to 1, right? So this is equal to h times s minus 1. Okay, so we substitute x minus x1 equal to h times s minus 1 into the formula. So now we substitute this one is equal to h times s minus 1. So this is how we get. So you see, sh times with h s minus 1. Now we have h and h, we have h squared. All right. So s and this one can be one group. So we have s times s minus 1 times h squared. Okay. So this is how we get this term. All right, and you proceed the next. Okay, this one you already know. This one is equal to sh. This one you already know. This is h times s minus 1. What about this? Okay, this is now your I is equal to n minus 1, right? So our x minus xn minus 1 is equal to h s minus our I is n minus 1. Okay, so this one you can simplify if you want. This is also equivalent to s minus n plus 1. Okay, and you substitute into here. Okay, so this is your h and then s minus n plus 1. Okay, so this is how we get here. Okay, you see, if you have, okay, you can see there is a similarity. Okay, let me highlight. Okay, so you see, if you have here is 1, here you have h power 1. If you here x2, here you have h squared. If you here have x3, here you have h cubed. If you have here you have n, you have a h power of n. Okay, so now what you can do will be next. I know that by using the binomial coefficient notation. Now, the binomial coefficient, this one you learn it in your statistic course, okay? So we can write the binomial coefficient in the form sk is equal to s factorial divided by s minus k factorial times k factorial. Okay, you've seen this one from statistic. Okay, so how you can do this? We know that s factorial, I can write it as s times s minus 1 factorial, right? And if you don't want, you can continue times s minus 2 times dot 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 times with your s minus, actually it's s minus your k minus 1. Okay, and next will be your s minus k factorial. Okay, so this is how we get it from here. Okay, next divided by s minus k. So you see your s minus k factorial, you can cancel this one and this one can be canceled. So now you left s minus 1. So the factorial on the top is already missing. it's not missing, it's already have been canceled, all right, has been canceled. So this is what we have, all right? So you substitute into the simplified Newton divided difference formula. So now, what is your x? We know that our x is this one, right? This is our x. So we can substitute the x is equal to x0 plus sh. So our p and x, so you substitute this x is equal to x0 plus sh. This is how we get it. Equal to fx0 plus, this is a simplified version because we can write it in this form, the summation. So the summation is from here until here. This is the summation part, okay? So when you write in terms of the summation, you get this one, all right? And I can simplify this one. You see, this is my SK, right? I don't want to write this because this is so long, all right? So I have this one, which is similar, you see? This one and this one, they are similar, right? Okay, so now what I'm gonna do is I move this k to this side, move it to that side. So that means I have sk times k factorial will be equal to s times s minus 1 times s minus 2 dot 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 up to s minus k plus 1. Substitute into here. So this is equal to sk times k factorial. Okay, so this is how we get these two terms. HK is still the same, so it's still the same. F is still the same, F is still the same. So you can, I would suggest that you memorize this formula. This is easier. Okay, let me do this. Okay, this one is easier to memorize. Okay, so now you are done. You get the equation C. So equation C, I rewrite Pnx equal to Pn x0 plus sh, okay, equal to your fx0 plus summation k equal to 1 to n. This is the binomial coefficient times k factorial times h power of k times f x0 x1 dot 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 up to xk. So we are going to use this one. Okay, so let us take a look for the next one. Give me a second. I want to begin with the Newton's forward difference formula. Okay, let me share this one here. Okay, so now let us take a look for the Newton forward difference formula. Okay, so now Newton forward difference formula can be constructed by making use of the forward difference notation. So this is the forward difference notation. Okay, you can use this notation introduced in the Eigen's triangle square method. Okay, so if you use this triangle, I call this as a triangle so that you can easily remember. So we get, okay, first fx0 x1, we know that this is the formula, right? And I can tell you that the difference between x1 minus x0, this is equivalent to the step size. So what does it mean? So this is x0, this is x1, this is your x2. So we know that the step size of this is h. They have an equal spacing h, okay? So this is x minus x0, this is equal to h. So I can write in terms of 1 over h times fx1 minus fx0. And now I can represent this one as triangle fx0. Okay, so this is how we get the simplified form. Okay, we can write it in terms of the triangle. Okay, next, if we have the second divided difference, this is the formula, right? So I can factorize, this is 1 over x 2 minus x0 times with, maybe I use a curly bracket, f xi, x1, x2 minus f x0, x1. Okay? x2 minus x0, we know that this one is actually equivalent to 2h. So this is how we get a 1 over 2h, and then you multiply by this one, okay? Next, fx1, x2, if you see from here, okay? So we know that fx1, fx0, x1 is equal to 1 over h triangle fx0, okay? If we have fx1, x2, we know that this is 1 over h times triangle fx1. So you have to remember, this one you take the first node, okay? So this is 1, so this is 1, okay? So be careful. So that's why I highlight it. So now I know that I have, this is actually equal to 1 over 2h times with fx1, x2, this is 1 over h triangle fx1 minus 1 over h, triangle, I missed my triangle, so I should have triangle fx0. Okay, so 1 over h, I can factorize it. Okay, so you can actually write this is something like this. They are similar. Okay, now I can factorize the h, factorize it. So I will have this is 1 over 2h times 1 over h times with triangle fx1 minus triangle fx0. So 1 over 2h times 1 over h, you get 1 over 2h squared times, because this one we can write this is equal to triangle square fx0. Okay, so this is how we get it. So I put it in this. See this. Maybe I should write it. So this is our f. So this is our f, x0, x1, x2. Okay, so now this is a general formula. Okay, so in general, we can write our fx0, x1 up to xk in this formula, 1 over k factorial, h power of k times triangle power of k fx0. Okay, so from the equation C, okay, what is the equation C? Okay, from the equation C, if you're referring to your notes, okay, so we have Pn x equal to Pn x0 plus sh. This is equal to f x0, okay, plus summation, okay, equal to 1. We have sk times k factorial h power of k, and then we have f x0, x1, dot, 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 up to xk. Okay, so this is our equation C. Okay, now, first of all, we know that this one is actually equal to fx0. Okay, next, from here, you can substitute this one. Can you see? I'm going to substitute this one into here, okay, into this term. Okay, so that means now this is equal to 1 over k factorial times h power of k times triangle power of k fx0. Okay, so what we can do, so you see now my focus is this one. Okay, I want to draw your attention. My focus is this one times with this one. Okay, so what we get, okay, so I write here, so we have k factorial times h power of k times with 1 over k factorial h power of k triangle power of k fx0. Okay, so now we can see that this k factorial and h power k can be cancelled. So we have this is actually equal to triangle power of k fx0. So this is how we get this. Okay, and this one you copy. Okay, that's it. All right. So this formula is a simpler form, and this formula is known as Newton forward difference formula. Okay, it is simpler form right now. Okay, so remember, this is a Newton forward difference formula. Okay, next, you know forward already. Now we learn the backward. So forward means that we start from x0, x1, x2, until xn. Backward, balik. Okay, it's an upside, it's another way around. So that means we start from the end to the initial. So means that we start from the endpoint, that is xn, then xn minus 1, then until x1, then x0. Okay, so this is the difference. All right, so forward, we consider x0, x1, x2, xn minus 1, and then xn. Backward is another way around. So we start from this one first, xn, then xn minus 1, then x2, then x1, and then x0. So this is the backward. Okay? So what you can do if backward, this one will be the form. We can write the interpolating polynomial in the backward. So this is the formula. Do you remember for the first one, we should have fx0, right? If you see the formula for the Pnx, so okay, the first formula here is fx0. Do you remember for the forward? So for the backward, we have fxn. You see, forward, this is the first node. Backward, this one is the first node. Okay, so it's the balik. All right, so you remember this formula. All right, so I'm not going to show you again. So this is the backward. So what you're gonna remember will be the nodes are equally spaced. Equally spaced. Okay, equally spaced, you know that the size in between x0 and x1 and x1 and x2, they are the same. Okay, and so on. Now, if the question gives you where the nodes are not equally spaced, so for example, I give you in between like this, okay? x0, x1. So for example, this is 0.5. Next, this is my x2. So this is a size, and x1, x2, this is 0.8. Then we know that this is not equally spaced, okay? If not equally spaced, we cannot use this formula, okay? We can only use this formula, the following formula. Okay, the following formula, I'm referring to this formula, okay? We can only use this formula provided it is equally spaced, all right? If it is not equally spaced, we cannot use this equation D, okay? So what you have to do, okay, for the forward, we have x is equal to x0 plus sh. Do you remember for the forward? So you see, forward difference. Oh, okay, I already skipped. The notes is not here. Okay, it's just now I have shown to you, right? So for that one, we have x equal to x0 plus sh. So forward, this is the first node, but for the backward, this is xn. So you need to be careful. Okay, so we have xn plus sh, and then your x is equal to xi plus s plus n minus I h. Okay, so Next one is you substitute your x. The way how you're gonna substitute your x, that is similar to what I have shown to you just now, okay, when we discussed about the Newton forward difference. So it's the same thing. So because this is your x, you substitute into here, okay? And you remember that your formula is, okay, let me write it at the bottom of this page, okay? Okay, so I hope that you still remember the Pn formula, okay? So we know that our Pnx is actually f x0 and then plus f x0 x1. Do you remember these? Okay, and then plus f x0 x1 x2 times with x minus x0 times x minus x1 plus blah blah blah. Okay, so it's the same thing. Okay, what we're gonna do, replace this one, okay, it's the same thing for the backward. We're using this formula, so you need to substitute what is x minus x0 x minus x1 here. So the same thing for the backward, we also do the same thing, but it just happened here is x minus xn. Okay, it's upside, it's another way around. If forward, here should be x0 x1, but if backward, we take xn and n minus 1. So if forward, we take these two, right? So if backward, we take these two. If you take x0, x1, x2, if you take these three, so next here you have an x and minus 2. So you're going to take these three. Okay? So you just go for the opposite way. All right? So this is the formula. What you're going to do, you need to substitute what is your x minus xn. What is here? Okay, you need to do the substitution. And again, okay, you do it and you will get this formula, equation D. All right. So next, for the forward, we know that we can use triangle to write in a simplified form, right? So for the backward, forward, we use triangle. For the backward, we also use triangle, but it's an upside down. It's an upside down triangle. Okay. This is triangle. This is an upside down triangle. So, okay. So what you're gonna do is the same thing. Okay. F xn and then xn minus 1. This is equivalent to 1 over h. This is the backward triangle. Okay. The upside down triangle fn. Okay. If you have this, it's also the same. Follow the forward. Okay. So the only thing you need to be careful will be here. This one, you take the first node. In the forward, the first node is x0. Do you remember? X0 is the first one. So here is the, but for the backward, the first node here is xn. So therefore here is xn. So here also the first node is xn. So here is xn. All right. So be careful of this. So they are the similar, just the way of you write. You must be careful what is for backward and then what is for forward, and then what are the differences. Okay, so this one will be the formula. All right. So next, what we're gonna look at will be the general formula for this term. Okay, it is equivalent to 1 over k factorial h power of k, and next multiply by the upside down triangle power of k times the not times, the upside down triangle k fn. Okay, you need to be careful. This is xn, not x0. X0 is for the forward. Okay, so what? Okay, now for the forward, I just write it down here just in case you want to compare. Okay, for the forward, we have f x0, x1, dot, 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 up to xk. This is equivalent to 1 over k factorial h power of k. Here is a triangle power of k fx0. Okay, so you need to be extra careful because forward, the first node is x0, so here is x0. Backward, the first node is xn, so here is xn. Okay, so they are similar, but you just remember this triangle is different. Okay, one is a triangle, one is an upside down triangle. All right. And next, you will using the same technique as I have shown in the Newton forward divider difference formula, and you will get this formula too. Okay. So, and the next one, if you write in the binomial coefficient notation, so this is the one that is a simplified version in the binomial coefficient notation. Okay, here, the negative sk, you need to be careful. This one, the formula is this one. Okay, you need to use it here because it's a backward. Okay, forward is with the positive s. Okay, so we know that this is the Newton backward difference formula. So you need to remember this. Okay, so this is the one. All right. Okay, next what we're gonna do will be, okay, you learn about forward, you learn about backward. Now we want to learn about the center. Okay, center. So the Newton forward and backward difference formula are not appropriate to approximate fx when x lies near the center of the table. Okay, so because forward take the most top, backward is take the end, okay, the end. So do you remember the forward, you consider x0, x1, and then dot, 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 up to xn. If backward, you start from xn, then xn minus 1, dot, 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 until the last one is x0, right? So what about in the center? If your x is right in between, okay, it's in the middle, then how? So if you use forward, it is not a good choice. If you choose the backward, it is also not a good choice, all right? Because they are located at the center. So what we're gonna do is now we are going to introduce you a center difference formula, okay? So this is what we are going to introduce to you, center difference formula. Now, we consider Stirling method, okay, to get this center difference formula, okay? Now, for the Stirling formula, okay, they may have other methods, but we only consider Stirling's method for this syllabus, for this course, all right? So for the Stirling's formula, this is a formula. It's a very long formula, I admit it, okay? It's not easy, okay? It's not easy to memorize, but you have no choice. You also have to memorize, okay? So that's why I ask you to come up your own notes, okay? Write down all the notes that comprise of all the formulas and algorithm, okay? Now, this is a Stirling formula, okay? Now, if n is odd, you take everything, all of this formula. But if your n is even number, okay, what color I should use? So maybe I use this blue. Okay, now if n equal to 2m plus 1, that means 2m plus 1 is odd, so 2m is even. So if n equal to 2m is even, that means we delete the last line, so we only consider the one in the blue box. So you delete the last line. This is for n is even. Take a note, okay, guys? So if n is an odd number, you take everything of the Stirling formula here. Take the everything in the red box. But if your n is even number, you only take the blue box. Okay? So this one you have to be careful. This last sentence, so let me highlight. This last line, the last line of this, okay, I highlight it. This one is only used if your n is odd. Okay, we only plus the last line of this if your n is odd. But if your n is an even number, we delete the highlight line. Okay, so I hope that you are clear. Okay, so next. Okay, I put a remark here. So you see, this is a remark that I have explained to you. Okay, so for the next, I would like to show you example, because by showing you example, you can see better. Okay. Now, let us take a look for example 14. So what you need to do first, you need to construct P3x, y P3, because you have 4 data points. Okay, so you have 4 data points. So you can construct P3x. If you have 5 data points, you can find P4x. Okay, so it is a number of data points minus 1. That will be your Pn. Okay, that fits the following data. Okay, so first we have to use Newton's divided difference. All right, always remember, if you want to use a Newton divided difference, first of all, you need to create a divided difference table. Okay, so from this table, I can create, okay, let me create this table. We add on. Guys, I'm here, I do not. If in the exam, you have to build a new table, all right? So here, because I have a limited space, so let me just continue with the given table here. Okay, so what you need to do is, first, I want to create the first divided difference table column, okay? Okay, what is this triangle representation? Can someone tell me? Remember, what is this formula? The formula is equivalent to f x I x1 minus f x0 divided by x1 minus x0. Am I correct? Let me check. I just want to make sure that I'm correct. I'm not writing a wrong formula. Let me check it out. It's my... Oops, I'm wrong. So this is like this. Okay. So this is the formula. Okay. Now here, what you're gonna do is this one. The formula is this one divided by x1 minus x0. Okay. So what you're gonna do? Okay. So maybe I write it like this. If you want to create this table, you can go ahead. Okay. So, okay, what I'm gonna do, I think I better do this f x I plus 1. Okay, so I don't want to do this, all right? So I don't want to do this. I think I have to do this one, is better. So this one, the next one is our f xi plus 1, xi plus 2. Okay. And the last one here, we have f xi dot 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 until xi plus 3. Okay. All right. So how to find the first divided difference? So we know that we have to take this value. So we know that this is our x0, this is our x1, this is our x2, this is our x3. We know that this is our fx0. We know that this is our fx1. This is our fx2. And this is our fx3. Okay? So the first one is we take fx1 minus fx0 divided by x1 minus x0. Okay? So the answer that I have obtained here is -7. Okay? Next, we take 5 fx2 minus fx1, that is 5 minus -4, divided by x2 minus x1, so that is 1 minus 0. So I obtain the answer is 9. Okay, and the next one is we take fx3 minus fx2 divided by x3 minus x2. So I get the answer is -11, right at the center, all right? In between these two, all right, we have -7. In between these two, we have 9. In between these two, we have -11. Next, to find this, the first one, so we know that, okay, let me write. So this is my f x0, x1. This one is my f x1, x2. This is my f x2, x3. Okay, so next I want to find what is my f x0, x1, x2. Okay, so this is equal to, so I'm going to take 9 minus -7 divided by x2 minus x0. Okay, so I get this is 8. So I have 9 minus -7, so that is 16, divided by 1 minus -1, so that is 2. So 16 divided by 2, I have 8. All right, and the next one is -11 minus 9, so I have -20, divided by x3 minus x1. So I have divided by 2 minus 0, I have 2. So -20 divided by 2, I have -10. Okay, so maybe I write in between. So this is my -10. I think, let me do this. Okay, this is my -10. Okay, and this value is represented by f x1, x2, x3. Okay, and next, the last one here, okay, that will be, I'm taking this -10 minus 8 divided by x3 minus x0. So I have divided by 2 minus -1. So I have -18 over 3. So I have -6. So this is -6. So this is equivalent to f x0, x1, dot, 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 up to x3. X2. Maybe I just write in full. Since I have space, I write in full. So X2 and then X3. This is equal to this value. Okay? So now, how we are going to use the Newton divided difference? First of all, make sure you write down the formula. Okay, so for the Newton divided difference, the formula will be, I write here. Pnx is equal to F x0 plus f x0 x1 times x minus x0. And next we plus f x0 x1 x2 times x minus x0 times x minus x1 dot 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 until the last one you plus, okay, plus dot 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 plus the last one is f x0 and then dot 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 until xn times with x minus x0 times dot 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 until the last one, that is x minus xn minus 1. Okay, so this is the Newton divided difference formula. I would like to write here because I have a lack of space here. Okay, so what I'm gonna do, okay, now you want to find P3, right? So now, okay, part A. Okay, so for the Newton divided difference, okay, for the Newton's divided difference, so I want to find P3x. So this is the formula for part A, okay, this is the formula. So P3, that means my n is equal to 3, right? So I know that I have fx0 plus fx0 x1 times x minus x0 plus fx0, x1, x2 times x minus x0 times x minus x1 plus with f x0, x1, x2, x3 times with x minus x0, x minus x1 times with x minus x2. Okay, so this is the formula. So what you're going to do next will be substitute the value, okay, you obtain from the table, okay? So you substitute all the value from the table, and I will give you the final answer that I have, okay? You do it at home, and the final answer that I have means that you have to substitute, okay, if you see from this table, right? You are going to substitute fx0 is 3, and then fx0 this one, and you need to substitute this value and this value into the formula. This is your x0, x1, x2, x3, you know, okay? You substitute into here, all right? So you will get the final answer that I have is negative 6x power of 3 plus 8x squared. You need to simplify, okay? Plus 7x minus 4. I give you the simplest form, okay? Sorry, this is minus 4. Okay, minus 4. Okay, so this is the answer. Go back home and try, okay? Any question, guys? Okay. Okay, sorry, guys. Okay. For the part B, okay, let me write here. Okay, for the part B, the general formula that you have, okay, let me write it here. For the part B, maybe I use green color, okay? So the general formula that we have for the Newton forward difference is Pnx is equal to Pn, the x is replaced by x0 plus sh, okay? That will be equal to fx0 plus the summation of k equal to 1 up to n, okay? And then you have the binomial coefficient sk, and with a triangle kfx0, okay? I just put the notes here where we know that our triangle kfx0, the formula is equal to k factorial times h power of k times with the f x0, x1, dot, 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 up to xk. So this is a formula for Newton forward difference. Okay, so for the part B, okay, guys, do you mind that I erase the solution here, okay, for the part A, because I need some space to write the solution for part B. So let me erase here. Okay, so for the part B, okay, it's the same thing. We want to find P3x. Okay, so now your n is equal to 3. So that means I have this is equal to P3. Now my x0, what is the value that I have for x0? X0 is -1, so you substitute -1. What is your h? Okay, to find the h, okay, let me erase this part. You can draw a number line to represent the knot. So here I have -1. You see, x0, okay, maybe I should put it like this. So this is my x0, which is equal to -1. And then I have my x1, which is equal to 0. Next, I have my x2, which is equal to 1. And I have my x3, which is equal to 2. So what is the difference between x0 and x1? So we have, in between you have -1 and 0, right? So it is 1. 0 minus -1, so I have 1. So x2 and x1, I have 1 minus 0. So the step size also 1. So in between x2 and x3, 2 minus 1, I also have 1. So you see, this is we know that our h is equal to 1. And this shows that it is an equal spacing. Okay, equal spacing, we can use the formula. All right, we can use the given, we can use the Newton forwards difference formula to find the answer. Okay, so we have an x0 here, which is equivalent to -1. So you substitute. What is your h? Your h is 1. 1 times s, you have s, so plus s. Okay, so we know that you can put the notes here. Okay, we have h is equal to xi plus 1 minus xi, right? So now we know that our h is equal to 1, okay? So what you have to do next, substitute into this, okay? Let me write down at here. Okay, we have the formula. So we have fx0 plus, what is your n? Your n is up to 3, okay? K equal to 1. And we have sk, and then we have this. Okay, okay, let me substitute. Okay, I will prefer I do this first. Okay, never mind, I do this one first. Okay, so now what I'm going to do, I know that. Okay, let me write it here. Okay, I need a space. Okay, this is equal to f x0. Actually, this is p3x. I just write it down in case some of you may confuse what I'm doing. -1 plus s. Okay, equal to this plus k equal to 1 sk. I'm gonna substitute this one, all right, with this one. Okay, put it here. Okay, so I have k factorial. H is 1. 1 power of k, what do you get? 1 power of anything, you get 1, right? So that means I have only k factorial. Okay, so, and then times with the f x0 x1 dot 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 up to xk. Okay, you can write here where my h power of k is equal to 1 power of k, which is equal to 1. Okay, so now we begin to substitute the value of fx0, or you want to expand first, also can. So this is fx0 plus, when k equal to 1, I have s1, and then 1 factorial is 1, okay? Times with a f, k is equal to 1, so that means I only have x0, x1, okay? Next, this is when k, okay, let me scroll down a bit. So this is when k equal to 1, okay? When k equal to 2, so I have s2 times 2 factorial times f. So the last point here is x2. So I have x0, x1, and then x2. Okay? So I know that this is for k equal to 2. Okay? Next, I have for k equal to 3. So I have s3 and then times with the 3 factorial. So this is f x0, x1, x2, x3. Okay, so I know that this is for k equal to 3. Okay, so what you have to do right now is we begin to substitute the value. Okay, so what is the value that you need? Okay, fx0. So this is the fx0. We need fx0, x1. So we need this fx0, this one, this one, and this one. So this is a meanings that we have to take the one that I've highlighted here. So you put it into the formula. Okay, substitute everything into the formula. And I actually get, okay, you go back home and try, okay, because I don't want to repeat again. So dot, and at the end I have, let me write it here a bit, okay. Okay, then you do it, dot, and I actually get this is equivalent to negative 6s cubed, okay, plus 26s squared minus 27s plus 3. Okay, go back home and try. Okay, next. Question asks you, you see question, if you give me this answer up to here, you will not get a full mark. Why? Because question asks you to find P3x in terms of x, not in terms of s. So you will not get full mark if you stop here. So what you need to do, you need to change the s into the x term, okay? So what you're gonna do is, okay, we know that, okay? Now, since we have h equal to 1 and we know that our x0 is equal to -1, then we know that our x is equal to x0 plus sh, right? So this means that we know that our x is equal to -1 is represent x0 plus s times 1, okay? So what is your s? So from here, I know that my s is equal to x plus 1. So what you need to do is, okay, I write here, this is the equation for P3, this is -1 plus s, okay? So now we need to substitute, okay, substitute x s equal to 1. I call this as equation. Let me put this, okay, this is actually, I still have something here, okay? Here is P3, okay? So I want to get a P3, okay? P3. Okay, so what I'm gonna do is I put this one as a star, equation star, okay? So now I'm gonna substitute s equal to x plus 1 into equation star, okay? So what you get? So I will get P3x, okay? Actually here, actually I should put like this. Actually, this is like this, okay? Is equal to P3 -1 plus S, now equal to, substitute the S with the X, okay? So I'm gonna substitute this S, this S, this S with this one, okay? This one, all right? So now I will have, this is -6 times X plus 1 cubed plus 26 times X plus 1 squared minus 27 times x plus 1 times 3, okay? So if you do the expansion, okay, next we continue, you will get the answer, you do it, blah, 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 and finally I will get my answer is -6x cubed plus 8x squared plus 7x minus 4. Then from here, you will get a full mark. Okay, what is the similarity if you notice? Okay, if you notice, this answer, okay, is similar to Newton divided difference final answer. You can check it out. Okay, they are similar. Okay, now any question, guys, so far? No question? Okay, guys, if you have no question, I think I need to stop here. Okay, now it's already 11:52. I don't think I have enough time for the part C and the D. So let me stop here. So if you have no other question, then that's all for our class today. And next week is our next week will be our SEM break. Okay, so I would like to wish you guys happy holiday and Selamat Hari Raya for those who celebrate the Hari Raya. So I will see you after next week. Okay. Oh, okay, I see. I'm not giving you slide. What do you mean by slide? Or do you mean the note or you mean the recording? Daniel or Jennifer? Oh, okay, the note. All right. Okay, I think I forget to give you the note. Okay, sure. I will give you guys later at through the WhatsApp group. Okay. So thank you for the reminder about the notes. All right. Okay, guys. If you have nothing, then no question, then I'm gonna stop.